All right, so now the next part of 6.1, this is still 6.1. So next part of 6.1 is we're going to talk about what's called regular polygons. All right, so we've already talked about equilateral and equiangular triangles. And we know when something is equilateral, even for polygons, it just means that every single side is the same. So if I say that a polygon is equilateral, it means that every single side is the same. All right, and then if I tell you it's an equiangular polygon, it means that every single angle is the same. Right, and they let us know that with all the arc marks. Now, if it's both equilateral and equiangular, it is called a regular polygon. All right, so that is both equilateral and equiangular. So if you hear me say a polygon is regular, you know that means every side is the same and every angle is the same as well. All right, so now we're going to use that information to solve for this problem. So it says a common housefly, Musca domestica, has eyes that consist of approximately 4,000 facets. Each facet is a regular hexagon. So they tell us each one is a regular hexagon. What is the measure of each interior angle in one hexagonal facet? So first off, we need to figure out how many sides is a hexagon. And a hexagon is a 6-sided polygon. All right, so 6 sides. So in order for us to figure out one interior angle measure, we need to figure out what all the interior angles add up to first. So we'll plug it into our formula. N minus 2, so the number of sides minus 2 times 180 degrees. So it'll be 6 minus 2 times 180. So 4 times 180 is equal to 720 degrees. All right, so that means every single angle, of this regular hexagon will add up to 720 degrees. So this plus this plus this plus this plus this plus this will all add up to 720 degrees. Now, there's a formula that we're going to use for this, but let's just think about this for a second. If each of these are the same and they're unknown, I can label one of them as x, which then means all of them will be labeled as x. So I know x plus x plus x plus x plus x plus x is equal to 720 degrees. So 6x is equal to 720, and I divide by 6, so x is equal to 120 degrees. So that means each interior angle for each of these facets is 120 degrees. Now, think about this formula and what we did here and how we can come up with the individual angle for each angle in a regular polygon. Right? So what we did is we had our original formula, m minus 2 times 180, to solve for the total sum, and then we ended up just dividing it by the number of angles that we have, which is equal to the number of sides that we have. So this is our formula. As you'll see, the measure of each, that means we're finding each individual interior angle of a regular n-gon, so whatever polygon, is exactly the formula that we just wrote, n minus 2 times 180, so this tells us the sum, and this is the number of angles that we have, so number of angles. Right? So that allows for us to solve for each interior angle. Now, if I just said find the sum of the sum of the angles of a regular polygon, then you don't divide it by n. So this is where a lot of people make mistakes on this. It's not that difficult. It's just people don't pay attention to the directions. And it might say find the sum, and they'll find the individual angle. Or it'll say find the individual angle, and they'll only find the sum. All right, so make sure you're paying attention to what the directions are asking for. All right, now the last question is find the missing angle. So in polygon TODAY, so that means this polygon here, solve for angle y. So what does angle y, what does the measure of angle y equal to? Oops. All right, and you are going to solve this, and you will create a new section, 6.1.2, and you will put this in your shared document, whether you type it up or take a picture. I'm fine with either one. All right, but this will be shared and handed in. So make sure you hand this in. All right, and that's it for this video.